Good morning students. Today we are going to discuss about electromechanical energy conversion part 2. Already part 1 discuss பண்ணிட்டோம். அதில் வந்து how the electrical energy is entirely converted into energy in the magnetic field. Correct? அதில் வந்து losses and mechanical output வந்து 0 வச்சுட்டோம் அந்த assumptionல. இப்போ பார்த்தீங்கன்னா field energy எப்படி வந்து is converted into mechanical force ன்னு பார்க்க போகிறோம். For that we are allowing some displacement. In first case the displacement is kept as 0. அந்த ஆர்மேச்சர் மூவே ஆகாது, இங்கே மூவ் ஆகிற மாதிரி வச்சுக்கிறோம் டு சம் டிஸ்டன்ஸ். ஓகே, dxன்றதுக்கு. ஸோ எனர்ஜி பேலன்ஸ் ஈக்குவேஷன் ஆஸ் யூஷுவல் எலக்ட்ரிக்கல் எனர்ஜி இன்புட் இஸ் ஈக்குவல் டு மெக்கானிக்கல் அவுட்புட் ப்ளஸ் சேஞ்ச் இன் எனர்ஜி இந்த மேக்னெட்டிக் ஃபீல்ட் ப்ளஸ் லாஸ். அகெயின் லாஸ் இஸ் ஈக்குவல் டு 0. இது ரெண்டும் இருக்குது. ஏன்னா மெக்கானிக்கல் அவுட்புட் வேணும் அப்படின்னா கண்டிப்பாக வந்து we are allowing some displacement. Correct? So we know change in electrical energy dW is change in mechanical output dWm plus change in energy stored in the magnetic field dWf. So dWe அப்படின்னா ID lambda. இது ஃபர்ஸ்ட் வீடியோவில் நம்ம டிஸ்கஸ் பண்ணோம். ID lambda. கரெக்ட்? D lambda. Okay, and then field energy வந்து பார்த்திங்கன்னா it is a function of two variables L and I. So energy-na WF function of lambda comma x integration of 0 over lambda. To remember this one we can draw I lambda curve. So in the curve கீழே இருக்கிறது, correct, கீழே இருக்கிற ஏரியா வந்து co-energy. This is co-energy. Correct? I hope you remember it. This is energy which is varied from 0 to lambda. Energy na 0 to lambda la vary ஆகும், co-energy na 0 to I la vary ஆகும். So WF of lambda comma x equal to integration of 0 over lambda I d lambda இருக்கும். இதே co-energy na WF dash of it's a function of I comma x which is equal to integration 0 to I lambda dot di. Okay, so நம்மளோட எய்ம் இங்கே என்ன அப்படின்னா if you are allowing displacement அப்படின்னா there will be decrease in energy and increase in co-energy proof பண்ண போகிறோம். Okay, so first I will take this energy in terms of co-energy. ஸோ எப்படி co-energy எடுக்கலாம் அப்படின்னா the entire area minus co-energy ன்னு போட்டிங்கன்னா we'll get this energy. So I had taken the differentiation of the entire area I lambda area minus co-energy. Correct? So that we will get energy, this energy. Correct? We have to differentiate this one. Okay, so first I will take this d of I lambda. இதில் எதுவுமே வந்து கான்ஸ்டன்ட் கிடையாது, ரெண்டுமே வந்து வேரியபிள். அப்போ எப்படி பண்ணணும்? ID lambda ப்ளஸ் lambda into di. கரெக்ட்? தென் இதை டிஃப்ரென்ஷியேட் பண்ணுறேன். இதை எப்படி டிஃப்ரென்ஷியேட் பண்ணுறேன் அப்படின்னா பார்ஷியல் ஃப்ராக்ஷன் ஆஸ் இட் இஸ் அ ஃபங்க்ஷன் ஆஃப் டூ வேரியபிள். கரெக்ட்? WFன்றது ஃபங்க்ஷன் ஆஃப் டூ வேரியபிள்ஸ். ஸோ dou f dash by dou I dot di plus dou f WF dash by dou x dot dx. Okay, just substituting these two in this first equation 1 ன்னு எடுத்துக்கிறோம். equation 1ல substitute பண்ணால் ID lambda minus the entire di lambda and this one differentiation இங்கே போட்டிருக்கோம். correct? So if I expand this I will get ID lambda minus lambda di. Okay, and actually you will get this as minus, no? So you will get this as minus, this also minus. Okay, okay, substituting all this differentiation of I lambda and differentiation of this WF dash over IX, no, in this equation 1. Okay, substituting in equation 1. Correct? So you'll get this one because this is minus, these two component will get minus here. When you multiply this you'll get plus. Okay, minus ID lambda, see here, minus ID lambda minus lambda into di. These two components are negative, hence we'll get positive. This is your dWm. So suppose if we have some displacement, I told you, correct, mechanical force is nothing but is having some displacement. Suppose the mechanical output is nothing but the force acting on that element with the displacement x. Okay, dWm is nothing but ff dot dx is equal to id lambda minus id lambda minus lambda di plus dou wf dash by dou I dot di plus dou f dash by dou x dot dx. So id lambda gets cancelled. Then whatever the thing we have, just write as it is. So minus lambda plus dou wf dash by dou I di plus dou wf dash by dou x, this is dou x dot dx. Okay, so ff is nothing but force acting on armature, dx is the displacement due to the force, displacement of armature, correct? So equating dx and di on LHS and RHS, we'll get, see here in LHS we have the coefficient of dx is ff only. Okay, ff is equal to, here we have dou wf dash by dou x. Then another one, no di component is, so here left hand side it is 0 is equal to minus lambda plus dou wf dash by dou I, which I can write this as dou wf dash as by dou I is equal to lambda, correct, and ff is equal to dou f dash by dou x. Okay, so what does it mean? The positive sign, this is dou. Okay, so the positive sign tells you there is an increase in co-energy while force is acting with some displacement dx, correct? And here the flux linkage is due to changes in current, correct? Hence it is a current excitation system. We can call this as current excitation system. Okay, and in second case, the same thing. Okay, case 2, here itself, if you express in terms of field energy, okay, same, dWm is equal to dWe minus dWf, correct? dWm is nothing but ff dot dx is equal to dWe is nothing but id lambda, முன்னாடி பண்ண மாதிரி தான், differentiation of differentiation of which is the function of field energy, correct? Function of lambda comma x, correct? So if we have this id lambda minus, so dou f by dou lambda dot d lambda plus dou wf divided by dou x dot dx. Okay, so just I'm rearranging this, d lambda plus dou w, this is minus, after that we'll get minus. Okay, expanding this, minus will go inside, dou wf by dou x dot dx. Okay, same manner if you compare LHS and RHS. Okay, if you compare LHS and RHS for dx and d lambda, okay, what we get, ff is equal to, very interesting thing, minus dou wf by dou x, which tells you, correct, field energy will be decreasing, correct? ஏதாவது ஃபோர்ஸ் ஆக்ட் ஆச்சுன்னா ஃபீல்ட் எனர்ஜி டிக்ரீஸ் ஆகும். அண்ட் comparing dl, left hand side is d lambda இல்லை, d lambda 0 is this is I, correct? So I minus dou wf by dou lambda, which is equal to dou wf by dou lambda is equal to I. Okay, so our conclusion from this is, we can say the change in flux linkage is because of voltage variation, hence it is a voltage excitation system. Okay, we can say like this, voltage excitation system. Okay, this is current excitation system. Okay, But anyhow, our conclusion is the force, correct? If there is a force on the armature with the displacement dx, then there will be increase in co-energy and decrease in field energy. This we can prove with the initial diagram. See here, this is our diagram. Suppose large air gap and it is moving to some position with the small air gap. Abdina, see, previously this is the co-energy area. Now once it is moved to this position, the co-energy area is increasing, energy area is decreasing. This is our final conclusion. Okay. In the case of rotary movement, the instead of force we say it as a torque. So torque either increase in co-energy or decrease in energy, correct? So though Wf dash by though theta, theta is angular displacement. Instead of x க்கு பதிலா இங்க theta போடணும் டார்க்னு இருந்தா, correct? Otherwise either dou Wf dash by dou theta or minus dou Wf by dou theta, which indicates a decrease in energy and increase in co-energy. Okay, thank you all for watching this.